Good afternoon, and thank you for joining today's webinar. I'm Florian Alami, and I'll be talking to you today about how to standardize and automate your ETABS model quality control. I'll start out with a brief review of use cases that we commonly see Visicon used for within our structural engineering clients. I'll then dive straight into 3 examples of where we're going to use predefined checking templates for 3 different ETABS models. Then I'm going to spend a few minutes showing you how to set up your own configuration for checking and saving those to templates. And then we'll hopefully have plenty of time for a Q&A session. So what are some of the common use cases that we see Visicon being used for, in particular when it comes to ETABS and the quality control scenarios? I would say first and foremost, it's usually a project manager or somebody leading a team where multiple people or different people are building ETABS models. And really the question comes up, what's a useful mechanism or tool for that individual to be able to quickly pick up various models at different stages of their development and quickly understand and do a review of what's going on. The second scenario is obviously a common one where a team member is taking over somebody else's project. Of course, you can take the model, you can analyze it, you can look at deflections, you can look at drift, but you still want to have a higher confidence level and understanding of what all the underlying modeling assumptions are. And that's really where Visicon comes in. You have progress monitoring and reporting. What I mean by this is we have clients that are either for internal purposes, every week that they meet with their teams, want to do a quality or a review to see what's changed in their models. And we have many clients that are actually using Visicon's reporting tools that I'll show you that are using Visicon to communicate outwardly in their submittals to their clients to show what changes they've made between various submittals, right? So this would supplement what they would send with a narrative potentially. Another common scenario is where the engineers that are, you have one set of people who are building the ETABS models and maintaining them. You have a separate group that are creating the construction documentation in, let's say, Revit. And the question is, what's the most effective way for the engineering team to transfer the knowledge, member sizes, sections, and all those things from their ETABS models back to the BIM team without just relying simply on screenshots? And that's where Visicon comes in. And then lastly, we actually do have quite a few customers that use Visicon to assist them as one of their tools when they're doing peer reviews of other projects. They use it not as to review the actual analysis solutions, but are using it to document and validate that certain assumptions were met in models. So those are the most common use cases. So let's, as promised, let's just dive into a couple examples. So we're going to start out in an ETABS model itself, just to take you through the complete process. So here the scenario is I'm the project manager, and I've just sent an email to one of my team members who's working on this particular project called Texas Tower. I want to review this project. So all that individual would have to do is go to File, Export, E2K. So now I can go ahead and actually save the E2K file. I'm going to set the units and we're done. So in this case, what we see, we've now created this file right here, which is an E2K file. All of the subsequent models that we open up will have already been converted to E2K, but I just want to highlight the fact that that's your starting point. Once you have access to an E2K file and you have Visicon installed, what you can do, I was just told that I am not sharing my screen. So what I had done is actually just exported to the E2K file. I'm opening up now the E2K file. So now we're in Visicon looking at a copy of that ETABS model that we just had in ETABS. If we zoom in, you can see you have access to all of the various components, like the loads right here, as well as all of the individual components. If I grab a component, you can see you have access to its general properties and all of its individual properties that came in through the E2K file. Right, so here you can see this is a column member. If I select a wall member, you also have access to all the information. It's very easy to come in here and turn on and off different components. So you can kind of quickly, for example, you just want to see your columns, walls, beams, and slabs. So this is the basic information or basic capability that the platform provides you. So here we've gone in, and again, I'm just highlighting some of the basics of the platform itself. So we've just, I highlighted that you can access all of the properties. We're going to create a new view, and in this view, all I want to do is just change the mode and just show how easy it is to come in. And for example, we want to just validate the geometry, because part of quality control, we're going to spend a lot of time on the properties, but part of quality control is also just making sure the geometry is as you want it. So you see here how I want to take a section at this transfer beam. I just click the face, right? I'm in my new view, and I'm adding a clip plane. So this is now a clip plane in this direction. And if I want to understand this connection deeper, I select this face as well, add another clip plane. So now I can nicely come in and view the details in an easy to navigate way for this connection. I can do markups and measurements. For right now, we'll just do a simple measurement because the architect wants to know what we're planning for in our clearances here. So I can now verify that my clearance here is 14.3 feet and my horizontal clearance is 5.167 feet. So this is how you can use the basic platform to investigate properties and geometry. Let's go back to our basic view. We had set this webinar up to say that I'm going to show you how to standardize and automate, right? So everything I've done so far was just kind of a manual, using our platform to manually see all of the properties. We're now going to apply a template that I've predefined based on the properties and the types of things that I'm looking for. So I'm going to go to File. You see here where I say Apply Template. So this is where I can come in and I can define all types of templates for the different types of ETABS models that I run. So for example, I created one for concrete review. I have one that we're going to use next for model changes. I have a different one for steel structures. We're going to apply the concrete review one. What that does is it just pre-populated all of these what are called checking rules. And so now it makes it really simple, right? We just went from ETABS to Visicon, explored the geometry, so we're comfortable with the geometry, and now I can start clicking through these various predefined checking rules. So for example, the first one says isolate and colorize piers. It's as simple as that. I click that and it is now color coding all of my isolating the members and color coding each of the components based on the pier label. So now I can come in as a project manager, I look at this and I say, here's an anomaly. Why is this, right? Because you can see by the color coding, this is pier SW-11, and so is this. And it's discontinuous between this pier S11A, right? So I could raises a flag. I can now go back to the design engineer and question whether this is intentional or is an oversight, right? We can look by, colorizing by section assignment. So in this case, we can see the variance of section assignment. So here, this slab is section S8C5, and then you jump down and it's S8C 5.75. Again, the purpose of this is for you as a project manager to make sure that all of the sections are uniformly applied where you would expect them. That was section assignment. Now we're color coding it by thickness, right? So now I can, with confidence, know that from the bottom here, so this is a 7-inch slab, all the way to yellow, 7-inch, we then jump to 8 inches and we keep the 8 inches. We have a transfer slab here that is different, so this is 10 inches. And even in this transfer slab, I have 3 thicknesses, 10 inches, 12 inches, and 16 inches. Can you see here at the bottom left, I'm highlighting the actual properties. So this just gives you a few examples of how to do these. This does not have any mesh elements. We'll do that in the next model, colorizing by material. So this shows how the materials change. So right, each of my various slabs. So here, again, I look here, this is material concrete 6500, and then it jumps to 7500, but it makes it very clear as far as doing that. We can isolate walls, and these are what are called compound rules. So here I'm looking at isolating a wall and just looking at the F11 modification factor, right? So I can quickly see that there's a variation here. Again, it is a basis of our team meeting for us to review, is this really what we intend to do and why are we doing it? Again, I can look at, this is F12, F22. So these are examples of how this is being used on this particular model. I'm going to go ahead and close it. And we're going to go to another project. So in this case, I'm going to skip the ETABS phase. We're going to go straight to the E2K file. So I'm double clicking on this. This just takes a second to load the first time. Once you save the E2K file as an Visicon file, it opens even faster. So here we have, again, a similar project. I'm going to turn off the loads. And what I want to demonstrate again is that same. You see, we have no rules predefined. This is a brand new model. I go to File, Apply Template. We're going to apply that same exact template. This is just to highlight the fact that this is how you can standardize your checking routines, right? We're going to go through the exact same checks on a different model. We're color coding it now based on peers, right? So I can see exactly what my peer assignments are, again, by sections. This time we have mesh elements. So I can also write equations. For example, here it's saying the slab property prototype slab and has a section area of less than 0.1 meters squared. So I'm isolating and looking for very small, shell elements. I don't find any. I jump it up one level, 0.2 meters, and I can see that we do actually, in fact, have a couple very narrow shell elements. I can live with them, or I might decide to go in and look at the meshing at certain locations. So this is another good tool that you can use to isolate and identify mesh components that don't quite meet, the ideal standard. Beams shorter than 1 meter, right? So this is just, again, we're isolating beams. And again, each one of these rules can be configured for certain visibility settings. So in this case, it says make the short beams yellow, and if they're not short, change the opacity to 5%. I'll go in and kind of explain how that works. Here again, we're colorizing by F11. Let's look at some other items. Here, let's look at the dead loads. So here we're color coding now our model to show the load, and in this case, only the dead loads. So this is a nice way to come in and see where I have uniform loads applied to the structure or not. And if you click here, you can then actually see, see the magnitude of the loads. Again, we're going to isolate the walls for F11. This is the same check we did before. And in this case, you can see there is a change in this F11, right? You can see here we're at 0.35 and here we're at 0.7, right? So this is, again, it's highlighting where there are changes. And I believe I was looking at this model earlier. One of these here, like you see here, there's one component we're checking the F12, that's at 0.5 and all of its surroundings are this. Now, again, I could question the engineer, is this intentional or not? So this, again, the point here was you can apply these templates and automatically run the checks and isolate all the key components. So let's close this and go to our third set of examples. So here we're going to open a brand new Visicon session. And this time I want to highlight how you can use Visicon to track the changes in models, right? That's another key component to quality control, right? Not only knowing what your model is made of at any one time, but also having a clear understanding and a record of how that model might have evolved. So in this case, we have two versions of a project that I've saved as an E2K file. You see here, Office Option 1, Office Option 2. I'm going to drag both of those into Visicon. Again, we have the two models. I'm going to, under visibility, turn off the loads. So what we're looking at here is a scenario where we're proposing two separate construction approaches or design approaches for the same project. And we want to be able to document this to our client, or we're checking it internally, right? If you go here, you can see we actually have two models. If I change the color, you can see that, superimposing the models and changing their colors helps a little bit, but it's not very clear as far as exactly what the changes are. If we look at our operations, they're blank. Similar to what we did for the checking rules, we're going to apply a template. In this case, we're going to call this ETABS model changes template, and it predefines all of the types of change configuration that I'm interested in. We're going to run the first one, which is a geometric Boolean difference. All the end user needs to do at this point is say, what versions of the models am I checking? I'm going to check version option, model option 1 against model option 2, and we're going to run this. It's now doing its mathematical computation. It has identified 282 3D differences between the models. We activate the visibility of this. And so what are we looking at? This is a clear graphical representation of how your two models have changed and the differences. If you look at the color coding here that you have control over, orange indicates where the mass of the model has reduced. So if we zoom in here, can you see that this shear wall is clear in the middle, which means that that is constant, that in option 1, right, because we're going from option 1 to option 2, in option 1 the shear wall was thicker, it has shrunk. This column was added, it's green. The shear wall was added in the middle here, it's green. So green means something was added, orange means it was removed. You can see how this column was in this orange kinked position and is now here. And if we don't see any color and everything's transparent, it gives us the confidence that no geometry has changed. We move up in the model and we see here that there's some change. And if we zoom in, Visicon clearly shows that in just for 3 levels to make this new alternative work, we had to actually come in and make the columns thicker. Do you see that? We didn't delete the columns, we didn't move them, we just simply made the columns thicker and it's still concentric. And that's what that green color coding there indicates, right? So that's how you do this. We're gonna come in and we're gonna say, not only do I wanna show where I changed geometry, but we also made some other changes in the model. Or maybe I'm just trying to find those changes. So here I can look at things like, wall thickness change, right? So I'm gonna come in and I'm gonna run this. And I have to just configure it, say model 1 against model 2. That was the message that I got, and I'm running it. So there are now these changes. And so what this does, a green means that the wall thickness didn't change. Orange means that a wall was added or removed. And orange means that the wall thickness changed at that location, right? So it's that clear, it gives you 3 very clear signals as far as how your model has evolved. Let's do the same thing for column material change. So we're now only interested in running a material change. Again, I forget that I have to say we're checking model 1 against model 2, activate it and run it. So there are 92 locations where the material changed. So right, if we look at the bottom, remember all of those graphical or geometric changes? But guess what? Here, the change in the model was only geometric. However, in the middle, not only did we change some of those central columns, we made those thicker, but we also changed the material property selectively of some of these columns. And you see they're highlighted in orange. What we're checking is the material assignment to see if that's changed. We can validate that by clicking on a component, and I can see that this is C18 in one of the models and it is material C12. I hit tab to switch to the next model, and this is now, let's see here. So this is C12 versus C10, right? One is part of model 1 and the other one is part of model 2. So this gives you the validation that that's actually where the material changed. So not only do you get all of this information graphically to help you with your decision making, if you need to, you can also prepare a lot of great reports. So here we have one report that was part of my template. So this report is already pre-configured to run the report for my column material change. So I'm just simply going to run this report, and it's going to give me an Excel report that outlines every single one of the columns that changed. And if I scroll to the right, it tells me exactly, right? This was in model A, this was column C7, it's called C7, it was C10 and has now been increased in material strength to C12. So this gives you a good overview of 3 clear examples where we've used the same template on 2 concrete projects and a change template on another set of models to be able to identify changes. So this is how you can standardize and automate the QA and control process. Let's close out of this and then quickly go through an example of how you can set these up yourself. How do you set up your own models? What I'll do is I'll open a model and we're going to create 1 or 2 simple checking rules ourselves, right? So this will just show you the simplicity with which you can define those rules so that you can capture and standardize the information that is important to your team and for a particular purpose. I'll show you how to set up the Boolean. That was taking 2 models and showing the geometric difference, setting up a variance check. So that was the example of identifying where material changed, and then saving all of this configuration into a template so that it's reusable across everybody in your office. Let's go to the Crystal Towers A and B. So what I've done is streamline the process further. As I had taken 2 models. There was that one project that we were looking at. And so this project, I believe we looked at the left one. In fact, this project is composed and modeled as 2 separate ETABS models, right? So there was this E2K file for Tower B, the E2K file for Tower A. I merged the 2 ETABS models in Visicon, so they're kind of next to each other. I can assign them a different color. I can also go to the color coding. What we're going to do is we're going to look here and we see that we have no rules. I want to show you how easy it is to bring in an ETABS model, pick a property that's important to you, and check it. So let's zoom in. Let's click one of these slab shell elements under parameters. If we scroll down, do you see there's a parameter called slab thickness? All you do is you're going to right click, copy this variable, right? Because again, we want to check this property, slab thickness. Under my rules, I'm going to create a new rule. The easiest type of rule to use is called uniqueness. So I just simply paste the property that I'm interested in under this uniqueness property. And when I hit return, it automatically color codes my model based on the unique thicknesses. So what is it telling us here, right? So if I look here, I can see that, let's say these pink slabs are all 23 millimeter thick slabs. You see 0.23. But there's a discrepancy at this roof level. On one tower, somebody put in 25 millimeters, on the other one 23. So that, I can't see a good reason for that, so we'd have to check why. If we scroll down, we can even see that there was a mistake here. This is a 45 millimeter and this is a 25. Again, the question being, what's the difference? Why are these not the same? We can drill down further if we click here. And for example, we go to the M11 modifier. Again, we copy this variable. We're going to create a new rule, drop that into uniqueness. And again, we can see where we have discrepancies. So again, 2 contiguous slabs, right? We're color coding based on, right? I would rename this. So I would say, color code by M, I believe this was M11, right? So here my M11 is 0.35, right next door is 0.25. So somebody's got to explain to me why these are different, right? So again, we can see same kind of differences here. Again, so highlighting how easy it is to set this up. We can also create expressions, right? So we're going to create a new expression and we'll do something simple. We'll take the slab, we'll do the thickness. So we'll do copy variable and we're going to paste that in here. So here we're going to reason about slab thickness and we're going to look for anywhere where the slab thickness is greater than 0.3, right? So more than 300 mm. If that condition passes, make the slab yellow, right? So we see now some of those slabs have been highlighted. And if the slab is not greater than 0.3 3 meters, make the color, for example, white. So we've just created together as a group a new coloring rule that says, color code all of my slabs that are greater than 0.3 yellow and turn all of the other slabs or elements white, right? You see, it's that simple. We can take the same thing, we come in File, apply our previously defined template, which was this concrete review. You see, it adds all of these other things. All of those previous rules, like isolating and color coding piers, follow no different logic than what I had just shown you, right? So that other pier that I showed you on those 2 examples simply says, do a unique color coding by assigned pier. And if you don't have the pier value, guess what? Just hide the components, right? So it hides all members that don't have a pier assignment. Perfect. So that's a simple review of how to define checking rules. So let's close this and let's go to our last example, which is setting up the Boolean and the material variance. So here I've now opened up, again, same as before, we have those 2 models. I go to my operation. It's blank. We're going to insert the Boolean difference operation. It's this simple to configure. We're going to do a solid volume comparison. It's already pre-configured for option 1 version, model 1 against model 2, and all I have to do is just simply run it, right? 282. So we're back at exactly where we were in our previous example, where we had applied this as a template. And we can see exactly how the models changed. If we want to do the variance on how is material assignment changed, I select a component. Similar to before, I just take any variable that I care about, in this case, core material, right click, copy the variable. So I'm going to copy the name. We're going to insert a variance check operation. We can give it a color. So we're going to make it this color. We're going to check option model 1 to model 2. We only want to see changes, modifications. You see here where it says variance to show, I just simply paste the property that I'm interested in. This could be any of the properties. In this case, it's the core material name, and run it. We have 92 examples of where the material changed. And you see it's highlighted those components for you. Each of those is associated with an issue, right? So this says, where's that column? That's this column right here. This is column C9. It changed from C10 to C12. Once you like the configuration of what you've done, you just simply come here, save as template. And then you just reapply those templates and can distribute these templates that you've created as standard checking rules to everybody in your company. In conclusion, what are the benefits of Visicon? The basic platform or the underlying platform allows you to gain faster insights into the actual product model information. That was a combination of better navigation, faster navigation, authoring solution, version independence, as well as cutting sections, marking up measurements, all of those things. Quickly verifying assumptions, that was primarily done through those rule sets, right? By being able to color code and isolate key properties that you're interested in. And then, as I showed you, through Boolean and the variance checking to identify and stay on top of model changes. And those combined or collectively lead to improved project team productivity and better project and model quality. For those of you that are interested, if you look out for the email that you'll receive, there'll also be a link to licensing and purchasing cost and options. So you'll be able to self-serve yourself on that link and procure a license on your own. We're here, we have great support. Like I had answered to one of the questions, we can help you set up your own configuration templates, but otherwise take advantage of the solution. That's a solution we created specifically for structural engineers to be able to have better control of their ETABS, Revit, Adapt, and IFC, so Tekla and other types of models. Thanks everybody for all the great attention, great questions, and apologize for the little hiccup with my screen sharing, and have a great rest of your afternoon. Thank you.